Yeah, go.
Okay. All right, now Maurice is going to read problem 8E, and we're going to solve it right before you. Remember, you have these solutions drawn out in great detail on the Resnick's presentation of the probability calculus PDF posted on Canvas, but now we're going to do them right before your eyes.
What is it if a red ball is drawn?
Okay, so what is the probability now that we drew from a type 1 urn given that we drew a red ball? All right, but again, this is a straightforward application of Bayes' theorem where P is the probability that we drew from type 1. Q is the probability now, not that we draw a blue ball, but we drew a red ball. Okay, so first of all, we need the prior probability that we drew from T. That is the probability of type 1 times the probability that we drew a red ball, given that we drew from type 1. All of that over the probability that we drew from type 1 times the probability that we drew a red ball, given that we drew from type 1, plus the probability that we drew not from type 1, meaning we drew from type 2, times the probability that we drew a red ball, given that we drew from type 2. Again, all I've done is just basically plug in the appropriate values into Bayes' theorem, where P is now drew a type 1 urn, Q is that we drew a red ball, and then this is the likelihood of a red ball given we drew from type 1, and probability of not P is now the probability that we drew from type 2, and the probability of the red ball being given from type 2. Now all we need to do is plug the basic values in and do the math. So the prior probability that we drew from type 1 is again 0.8. 8 out of 10 of those urns in the room are type 1. The probability that we drew a red ball, given that we drew from type 1, is now 4 out of 10, because there are 4 red balls in each of the type 1 urns in the room. So that same number plus the probability that we drew from a type 2 urn, well, that's only 0.2, times the probability that we drew a red ball, given we drew from type 2. That number, however, now is 0.9, because 9 of those balls in the type 2 urns out of every 10 is red. Now when we do our basic math, we get 0.32 over 0.32 plus 0.18. 0.32 over 0.5 equals 0.64. Notice what has happened now. The prior probability that we drew from a type 1 urn is 0.8. But the probability that we drew from a type 1 urn, given that we drew a red ball, falls now to 0.64. Look, it's still likely that we drew from a type 1 urn, because 8 out of every 10 urns in that room is of type 1, and if we just randomly chose one, the prior probability